So this intelligence theorem has the wide applications, that it is applicable for linear, non-linear, time variant, time invariant, like many things are there. You will understand what is mean by time variant, time invariant later on. But as of now, let me give some generalized thing about the intelligence theorem is that if we consider two networks which have similar structure with different elements, it may have similar structure but different element. This is the condition. For such a networks, if Vk1 is the k branch voltage and Ik1 is the kth branch current of the network 1 and Vk2, Ik2 are the branch voltages and currents in network 2. Then according to intelligence theorem, what it says is that, see, this is very important observation, carefully observe. The network 1 voltages into network 2 currents of the corresponding branches. See that Vk1 is the first network voltage, Ik2 is the second network kth branch current. If we add up network 1 voltages into network 2 currents for all the branches for k is equal to 1 to b, it should give the 0. This is very interesting. Next is network 1, let us say network 2 voltages Vk2 product with the network 1 currents also will give the 0. Not only this, you can see that one more interesting phenomena. If network 1 voltages and currents are measured at t1 instant, if network 2 voltages and currents are measured at t2 instant, now it is applicable in this way that Vk1 t1 instant into Ik2 t2 instant means different times. We are measuring the network 1 voltages currents at t1 instant, whereas network 2 voltages and currents at t2 instant. Even though different times, you will get the algebraic sum of the powers equal to 0. So these are the three important things which you should observe later on once you understand these network theorems and entire circuit analysis gist. In the network theory or network analysis subject, you will learn the application of these three equations which are very much helpful. Now let me give one example for these statements. This is also intelligence theorem. See that here I have the similar pattern of the structure of the circuit. Here see, let me name something like this. This is node N1. So this is node N2, and see that you have, somehow you can assume in this way, in the graph theory or network theory, we have this entire thing is one element which is a practical voltage source. Voltage source in series with resistance can be treated as a practical voltage source. Similarly, this entire thing is one more branch, second branch, and this middle one is one more branch, only resistor. So two voltage sources of practical values is connected with one resistor. That is the circuit pattern structure. Now same structure you can observe that here is one voltage source but different values. So see, elements are different but structure remains same. One voltage source. This side one voltage source but zero value. Voltage source value here is 0 but has a series resistor. So this will have same structure. So one more thing is resistor. So this one as usual. Now for these networks, let me name this as circuit 1, this as circuit 2. So this green color one I will consider in which, so if you want again sub branches also you can consider. So you can let me name this as 1, or directly let me find directly. So all the branch voltages and currents let us find first. Okay, so as like in the previous case, so how we proceed? So you can proceed in many ways. So which one we take, either nodal or mesh, whatever it is. So let me take the nodal analysis. This node is the reference node with respect to this. So this node voltage is Vx. Now tell me, so by using KCL, if I write KCL at node N1, what I'll get? Vx minus 5 divided by 1 plus Vx by 2 plus Vx minus of minus 2 divided by 2 is equal to 0. How much is the Vx? 1 by 1 plus 1 by 2 plus 1 by 2 whole into Vx, and what is left constants here? 5 will be there. If it goes to right side, plus 5. So here 2 by 2 is 1, so plus, but it will come as a minus, so it is 4. And how much is this value? 1 by 2, 1 by 2, 1. So this becomes 2 Vx. Ultimately, what is Vx? 2 volts. Now once Vx is known, so I can make the calculations in this way directly. So this branch current I will write directly, see here. So Vx is 2, so this voltage is higher than this, so current will flow in this way as 5 minus 2 by 1. Yes or no? This branch current, let us say some I1. How much is I1? I1 is equal to 5 minus Vx, that is 2 divided by 1, which is equal to 3 amperes. Next is, so which voltage is higher? This is 2 and this also 2. Then let us see how much will be the current. This I2. So for this branch, I2 is, so Vx minus of minus 2 divided by how much is the resistance? 2. So how much we will get? 4 by 2 is equal to 2 amperes. So next is this branch current, let me consider as I3. So I3. So how much is I3? Vx by 2. Vx by 2. So that is 2 by 2 is equal to 1 ampere.
1 ampere.
Now what I will do is that for the circuit 2, whatever I did here, I try to do same thing. What I will do, see here carefully. Here also same thing, like node N2. This is node N1. Okay. Next is this node voltage. What I will assume is Vx dash, which represents second circuit. And this current I will consider as I1 dash, or before that, first let me find Vx dash as like this. So now what I will do? KCL, let me choose different color. KCL at node N1 for this second circuit. What I will get? Vx dash minus 10 divided by 2.
Sir,
Yes, please. Yes, please. Is there any doubts?
ఫస్ట్ సర్క్యూట్ లో కరెంట్ డైరెక్షన్స్ ఎలా చేశారు సార్?
That I generally assume. You can take in your own way, but as per
ఫస్ట్
this,
సర్క్యూట్ లో కరెంట్ డైరెక్షన్స్ ఎలా తీసుకున్నారు సార్ రిజల్ట్ గా అంటున్నారు.
yeah, I am repeating that point. So question is that how we taken the current directions. Okay. So generally try to observe this 1 ohm resistor. Where it is connected? It is connected at these two terminals, here and here. One side is 5 volts, other side is Vx. How much is the Vx? 2. So usually current will flow from higher potential to lower potential. So based on that, I already know the voltages. That's why in reality I consider in this way, that higher to lower side. That is one thing. And here it's your wish. You can consider in either way. Okay.
Okay, advance.
Even if somebody consider reverse way, no issue. You may get negative value. For example, if you consider opposite to this, then what will be your current is I1. So Vx minus 5 by 1. So you may get same value but negative current, no issue. So you can consider in that way also. Clear? Right. So now let us take the circuit 2. Now as of now I am not talking about Telegen's theorem. I am in the process of finding every branch voltages and currents. Right. So let me take this and Vx by 1 and what last one is Vx dash divided by 2 is equal to 0. So how much is Vx? So Vx dash 1 by 2 plus 1 uh, plus 1 by 2, right? So this will gives the 5. So Vx dash is equal to this entire thing is 1 by 2 plus 2. So this is 5 by 2 which is equal to 2.5 volts. Okay. Now after getting this, in the same way as like circuit 1, I will consider some currents. This is I1 dash. So this is I2 dash and here is I3 dash. Whatever currents I considered in circuit 1, same currents but with I1. Okay. Let us see what are those currents. I1 dash, how much is the I1 dash? I1 dash is equal to, so 10 minus Vx dash by 2. So 10,
3.75.
3.75. Give me the most accurate value. So don't take fraction, means uh, like don't round up the things. So 15,
3.75, sir.
yeah. So 3.75 amperes. Next is I2 dash, I2 dash, I2 dash is Vx dash by 2. So that is 2.5 by 2. So 2.5 by 2,
1.25.
1.25, sir.
1.25. Very good. So next is what else is I3 dash
2.5.
2.5 Vx by 1, Vx dash by 1 which is 2.5 amperes. Now see how I will apply the Telegen's theorem is that very carefully observe. I will take the first circuit voltages, second circuit currents. Okay. First circuit each branch voltage and second circuit currents. Okay. So see that first circuit this corresponding branch voltage, how much is the voltage? 5 volts. How much is its current? I1. Okay. Is this clear? Similarly, here that same corresponding branch, how much is the voltage? 10 volts. What is its current? I1 dash. Got my point? Next is this branch voltage 5 minus Vx, whereas this branch voltage is, let me write here. Why? Because these are helpful. So 5 minus Vx, this downside positive, upper side negative. And downside positive, upper side negative. How much is the voltage? 10 minus Vx dash. 10 minus Vx dash. Like that we should have every branch voltage first. So here also let me take this voltage is Vx minus of minus, that is 2, that is Vx plus 2. Here how much is the voltage? Simply Vx dash. Okay. So now I know every branch voltage and current. What I will do is that I will take, let me write here, first circuit voltages and second circuit currents. What I am doing, the circuit structure remains same. See, both circuits have same structure. That's why I am taking first circuit voltages, second circuit currents as like this one. See this? I want to see whether adding all the powers whether it is 0 or not, that I want to check it. Okay, so let me take. So here how much is the voltage? 5. How much is the current? I1 dash. Let me write that. So 5 into I1 dash. Is it positive or negative? Is I1 dash entering or I1 entering at the negative terminal or positive terminal? Negative terminal, right?
Negative, sir.
So negative. Next. Second is 1 ohm. 1 ohm voltage how much? 5 minus Vx. How much is Vx? 2. So 5 minus Vx is 3 volts. So 3 into its corresponding branch current here. I1 dash. Let me write I1 dash. Later I will substitute I1 dash. Next is here this I3, and you can take this second branch also. How much is the voltage? Vx plus 2. Vx plus 2. How much is its corresponding current? I2 dash. This current I2 dash. Okay. So next this third resistor. So how much is the voltage? Vx. How much is its corresponding second branch current? I3 dash. Next. Here how much is the voltage for this? Voltage 2 volts. How much is the current here in this branch? You should carefully observe here some voltage may be there whose value is 0 volts. That is the meaning. Okay, so here negative, here positive, same polarity should be carry forward. Now current flowing through this is what? I2 dash, where it is entering negative terminal. So as because this is let me write I2 dash, but what is the polarity? This one negative. This term is very carefully you should write. Okay, so I hope all the branches completed. So 2 into this current is entering at the negative terminal, so I took the power to be negative, so is equal to 0, or we will check whether it is 0 or not. So what we will do, substitute all things, substitute all the things. Now give me firstly all these values. So minus 5 into I1 dash, I1 dash 3.75,
2.7.
right? Next, plus 3 into I1 dash, again I can make even these two together, minus 5 plus 3, so minus 2 into I1 dash is 3.75. Directly I am writing, don't get confused, these two terms together. Okay, right. Next is Vx. Vx is 2. 2 plus 2 is 4. 4 into I2 dash, I2 dash 1.25. Next, Vx is 2 again, I3 dash into 2.5. Next, minus 2 into I2 dash 1.25. How much is this value? Check it carefully. 2 into 3.75 plus 4 into 1.25.
0, sir.
0. Very good. So 2 into 2.5 and minus 2 into 1.25 is equal to 0. See, excellent. See, what we did is not surprising that one circuit voltages, other circuit currents is giving us the Telegen's theorem that power to be 0. But the condition is that it must have similar structure. Elements may be different, no issue. Same or different, it doesn't matter. See, here elements, is it different or not? 10 volts, here 5 volts. Here 2 ohms, here 1 ohm. Here 0 volts, here 2 volts. Like that. So structure remains same, but still it is means these elements are different, still it holding the intelligence theorem that one circuit voltages, other circuit currents. Now can you verify, as because we did all calculations, so can you verify that this statement in different way as like this? Let me put here. What I will do is that first circuit currents, second circuit voltages. Can you verify this statement? So you write down, cross verify whether you will get 0 or not. That is very interesting. But circuit pattern should be same. This is what the intelligence theorem, and this is little bit advanced in level. So, but you should understand these things very carefully, which is very much helpful in the network theory or network analysis. Clear?